Hey everybody, welcome back. This is part two of our video on characteristics of quadratic equations. It got a little long last time, so I decided to end it. So this will be the second part, and all the things we did and talked about in the first one are still true, but we can find a lot of them using our calculator, so we don't have to really do a lot of things by hand. The problem is there's just a lot of buttons, and if you don't really know where they are and what they do, it can still be a challenge. So what we can do, and you saw me do this a couple times in the last one, where we can hit the y equals button up in the top and we can enter equations into it. Okay, sometimes, again, we had to alter the size of the window that you see on your graph, because really this is the default screen that goes from -10 to 10 in 4 directions, so it's a 10 by 10 square that has a scale of 1. So sometimes we have to adjust it. And we can always write down our settings really using this kind of format. So you're always going to see me write them with the minimum value first, the maximum second, and then the scale. So you can do it for x and y so that somebody looking at it can reproduce that picture on their calculators. We can go calculate the vertex as well using either a maximum or a minimum. So this page will tell you all the buttons and steps to do it. So we'll do a couple of these together. Now this is the important part, step 3, because your cursor has to be on the left and right side of that vertex. So we'll do this a couple times here. Determine the vertex of this graphically. So we'll go graph it first. So step 1, hit your y equals button, graph your equation. So x squared minus 5x plus 4. And then hit graph. There's the picture. So I know it opens upwards. So I know I'm going to have a minimum. So I'll write down our window settings. So if you hit the button that says window, it'll tell you all of them. So here's our window settings. So for x, the minimum is -10, the maximum is +10, the scale is 1. Really, we didn't change anything. For the y, the same scale. So 10 by 10 square to do this. Axis of symmetry. Again, that comes from the x value of the vertex. So I have to find that vertex first. So we can hit the second key and then trace. So we'll bring up our large calculate menu, and options 3 and 4 tell us if it's a minimum or maximum. Now I know this opens upwards, so I know I have a minimum. So I'm going to scroll down to option 3 and then press enter. And now your calculator is going to ask you 3 questions. Left boundary. So you need to set the boundary your calculator will search in between. So put your cursor on the left side of your vertex and then press enter. You'll see a little triangle come up. Then the question will change to say right bound. So move your cursor to the right side of your vertex. Hit enter again, and there is your other boundary. So your calculator will look in between those triangles for the vertex. Once you hit enter again, if it says guess, press enter, and it will tell you your vertex, and there's the values of it really. So we can round those numbers. So my vertex for B has the coordinates when x is 2.5, y is going to be -2.25. Okay, so there's my vertex coordinates right from my calculator. It tells me x and y. That means that my axis of symmetry is x is equal to 2.5. Right, it goes through the x coordinate of that vertex, so there it is. When x is 2.5, there's a vertical line that will cut it in half, just like before. Domain and range, again, well, x won't change. It's always any real number. But for y, it comes from, again, our vertex. So y has to be greater than or equal to -2.25. And I know it has to be greater than because it's a minimum and everything else must be larger than it. Everything's above it, so that's how I know it's a greater than. Okay, so as long as I can find it using my calculator, I can still answer all the same things as before. Okay, we can do a little bit of a word problem here too, and I think that's the last one. It's got a few parts to it. So the skier's jump was recorded frame by frame, so we could look at it. And what you'll notice is if I just highlight them, you follow that parabola path. Really, that's what it looks like if I were to actually put it on a grid. Right, it might look something like this. Right, the red lines as being my axis lines. Okay, so this picture was used to determine the quadratic function that relates to their height Their height is in meters, that's y, and x is time. And the equation given to us by, negative 4.9x squared plus 15x plus 1. Graph the function in your calculator, sketch the graph. So let's go graph it first. So negative 4.9x squared plus 15x plus 1. Be careful not to use the subtraction key here for your negative, or else your calculator won't do what you want. It'll tell you there's an error. The negative sign is the one that's down at the bottom next to enter. So just make sure you use that one. Press graph. Now what you'll see is it's not a good picture really, because I can't really see the top part of it, and I really only care about part of this graph, because you think about the variables. If x means time, x can't be negative, so I don't really care about any negative x values. And if y means height, I don't care about any negative values for height. The skier's not going to go through the ground, right? That's not going to happen. They're going to hit the ground and stop. So I need to account for this. So when I hit window, x minimum, again x is time, so let's start our time at 0. So our scale for x, the minimum's going to be 0. Maximum, I guess we can leave at 10 for now. Scale of still 1. And for y minimum, again, we'll make that 0. 10 wasn't big enough to see the maximum, so let's make it 20. We'll double it, and then we'll keep the scale still at 1. So we'll graph this, see how this goes. Much better picture, in terms of this situation. X maximum might still be too big because I'm not using a lot of the graph, so let's change that to maybe 6, and that should probably zoom in a lot more for us. So that looks a lot better. So instead of 10, I'll change it to 6. Okay, so let's go graph this. So I'll go to my table of values so I can get some important points from it. So second graph will bring up your table. So when x is 0, y is 1. There's my y-intercept. And I'm going to pick some easy points to graph. So I'll just maybe scroll around here. So no negatives for x. So go up from there. There's not too many easy ones to really graph, because they all end up being, partials, because as soon as x is 4, I'm like way underneath already if I look at my graph. So anything more than 4 is no good, but less than 4 is okay. So if it's 2, it's just more than 11, so we'll make a rough estimate here on, where this happens to be, and that's 11.4 for 2, yeah, okay. 3 comes back down to about 2. Okay, so 1.9. So right about there. And 4 is already negative, so that's just too far. So here I've got a good idea of what this graph may look like. Now it's not perfect, but it really just gets us enough to look at. Right, so 1, 2, just over 3 is where I hit 0. So really, all I really need, right about there. Okay, so there's the graph of this situation. Now, it's not perfect, I'm not an artist, but it gets the sketch across. Determine the skier's maximum height to the nearest tenth. Well, if I think about how they've worded that, they literally use the word maximum. So I really just care about the vertex here. And what we saw we could do is we can find it with the calculator. Right, so let's go use our calculator to do this. So second trace, option number 4 this time is maximum. And again, I'm trying to really do the same thing. Put the cursor on the left side of your vertex. Anywhere, it doesn't have to be close, far, anywhere is fine. Hit enter. Move it over to the right side of that vertex as well. Okay, now I've got 2 boundaries. My calculator will search in between them when I hit enter. So here's my vertex. Right, there's the maximum. Now, this is telling me 2 specific numbers, right? X represents a variable here. Y also represents a variable. Now, if I'm looking for their height, height was represented by y. And it says the nearest tenth, so here y is going to equal to 12.5 meters. I have to round it because it's 12.47. So 12.5 is their height. Part C then says, when to the nearest tenth did they reach the maximum height? So they reached the maximum height at the x value of that vertex, right? To the nearest tenth again, 1.5 seconds. Okay, that's what my variables are defined as. X was the time in seconds, Y was the height in meters. So I've got my two things, straight from my calculator vertex. State the range of this, and then we'll do, I think, domain as well. But the range of this, range talks about Y values, right? Which is really us talking about height here. So I know that the lowest height this could be is, well, 0. They could be at ground level. So my set of Y values, given the restriction, that 0 is the smallest, but 0 has to be less than my Y value. In other words, Y has to be bigger than 0, but Y also has to be less than the maximum, which is 12.5. So now I'm locked into being in between two values, where I still could be equal to either of them. But now Y could be any real number in between. So really, here's my range of values in red. From top to bottom, I could really be anything in between there, right? So the maximum Y value is 12.5. The minimum Y value is 0. So my inequality says that as long as Y is bigger than 0, but less than 12.5, I can be anywhere in this situation. Okay, so there's my range. What is the y-intercept of this? Now your calculator can find this as well, and which is what the note here tells you. So second trace, option number 1 allows us to input a value, and I want to input a value of x as 0. That'll give me my y-intercept. When I hit enter, it tells me it's 1. And what you'll notice again is in the equation, it's always the constant, right? It's what we talked about in the last video. So I know that my y-intercept is when x is 0, y is 1, and it tells me that I'm really not starting this jump from the ground, right? The hill is a meter off the ground. Right, it's 1 meter off the ground. And really, if you look at the picture, you can see that, right? It's not ground level because they are a meter really above the ground. So I should adjust my, axes here. Now, now based on what we know, right, really it's something like this. Right, they're not starting from ground level, they're starting above it because the ramp is up there. Which makes a lot of sense when you think about it. Part F says the next day of training, the skier increased their speed before taking the same jump. The equation that models their new jump is given. How much higher did they go on this jump? Well, we can graph two equations on the same thing. So I'm going to press the down arrow on y equals and go into y2. And if I go to the left, I can make it a bolded line by scrolling all the way left and hitting enter. And you'll see the thickness of that line change. So I'm going to put in the other equation, so negative 4.9 x squared plus 17x plus 1. And then if I hit graph, what you'll see is the new jump graph there as well. So the skinny line was the original, the bolded is the new one. So let's go find our new vertex, because they've jumped higher now. And if I hit second trace, I'm going to need to make sure I'm on the right line. So it says y1 in the top, which was my original. If I press up, it'll change me to y2, which is the new one. And then we'll do the same thing. So left bound, right bound, guess. So move it all the way left, enter. Move it all the way right, so you're just on the other side of it. Doesn't really matter how far you go. Enter again, enter one more time. Here's your new vertex. So let me change the color here. The new max height is equal to the nearest tenth 15.7 meters. The old maximum height, we found it previously, was 12.5 meters. So if I subtract those two numbers now, 15.7 minus 12.5, well, now I know that they went 3.2 meters higher, higher than before. Right? I could find the new maximum, compare it to the old one, so I know they went 3.2 meters higher than before. Okay, so that actually concludes that first lesson finally. And at the end of this, what you'll see is a summary of all the important things we talked about. Okay, all the properties, all the, if A is positive or negative, that'll be there as well. And what you'll also find at the bottom of each set of notes here are a bunch of practice questions. And they are coded, easy, medium, a little bit more difficult. And so you can take a scroll through them, try them out, and I'll have the answers for you right at the bottom. So I'll include that in the document as well that you're going to get. But there are all the answers already there for you. So try them out, see how they go. And a really good way to check your understanding here as you go through this unit and all of the other future units as well in this. So that wraps up our first lesson. You'll see the second one again linked up above in the top right corner, and all the links to everything that you'll need you'll find in the description box like you have for all of the other ones. So I hope that was beneficial. I hope that it helped increase your understanding as well. So we'll see you in the third video. Until then, take care of yourselves. We'll see you next time.